Alright, so today's lecture video is covering section 8.4, Properties of Rhombuses, Rectangles, and Squares. And basically, as we're going to find out today, these are just special types of parallelograms. They're all still quadrilaterals, they're all still just four sides, but they're very specific types of parallelograms. So to start, we have a bunch of definitions and theorems. So again, pause the video to write down your theorems, follow along in your textbook, or go look at the notes I've also posted on Classroom to get the notes you need. Our first set of theorems all go with the rhombus. And basically, our rhombus corollary says a quadrilateral is a rhombus if and only if it has four congruent sides. So all four sides are congruent, means it's a rhombus. When it comes to the diagonals, a parallelogram is a rhombus if and only if the diagonals are perpendicular, which means it creates a 90-degree angle, as we can see right there. And then our second theorem for the diagonals in a rhombus is a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So it bisects the angle the diagonal is connected from. All right, so we know they intersect and create a 90-degree angle, and they also bisect opposite angles. And those are our three theorems for a rhombus. Again, pause the video, take your time to write these down, follow along online with the slides that are posted on Classroom. You're going to want these theorems somewhere that you can use when you're going to solve problems. But those are our three specific theorems about a rhombus. So then a rectangle, a little bit different. A quadrilateral is a rectangle if and only if it has four right angles. So we know in a rectangle back from like grade school, rectangle has four right angles, which means they're all 90 degrees, right? Right angle means it's 90 degrees. That will come into play. And then it also has a theorem about its diagonals. A parallelogram is a rectangle if and only if its diagonals are congruent. So not only do they bisect each other, but they're also congruent, meaning they're the equal length. They're all going to be equal. Everything in a rectangle is equal. All the angles equal 90. Diagonals are the same as well. So then on to the square. Our square corollary says a quadrilateral is a square if and only if it is both a rhombus and a rectangle. So a square is like best of both worlds. It's also a rhombus and a rectangle. And here's a list of all the properties it has. Since it's a rhombus, it has four congruent sides. Since it's a rectangle, it has four right angles. Since it's a rhombus, the diagonals are perpendicular when they intersect. Since it's also a rhombus, diagonals bisect opposite angles. And then since it's a rectangle, diagonals are congruent. And something I want to point out here before we move on is that they're all still parallelograms, meaning opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, and opposite sides are parallel. They're all still parallelograms, so they still fit all of those properties that we worked on in the last two sections, and now these have that special one or two theorems that are unique to each of these types of parallelograms. So what does that look like when we're comparing them all together? Well, we can use a little Venn diagram like we have here. Here's kind of how they're all related. Parallelogram is like the big, broad spectrum. It covers generally a lot of different types of shapes. They can look different. They can have all these different properties. Parallelograms like the most general. And then getting more specific, we either have a rhombus or a rectangle, which we can see here, kind of our little two identifying things. A rhombus has four congruent sides. A rectangle has four right angles. And then in between both of those, we have the squares, which is both of these put together into one. Square is kind of like that. I like to think of it as like that perfect shape. You can't be using my air quotes around it, but it's like that perfect shape because it's the best of both worlds and fits both of these properties. But they are all still parallelograms. So keep that in mind as we move through some different examples. Again, hopefully you guys paused the video and wrote some of those down so you have them where you can see them and use for these problems. For any rhombus, QRST, decide whether the statement is always or sometimes true. Draw a sketch and explain your reasoning. So let's draw it first. Just kind of get it out of the way. Let's go ahead and draw it. We have a rhombus, so I'm going to do my best to kind of draw a rhombus here. It's like basically a little diamond thing. Doesn't have to be perfect. And it's QRST. And we want to decide, is angle Q always congruent to angle S? Always or sometimes? True. Well, going back to our theorems for it, they're opposite angles. Angle Q and angle S are opposite angles, and we know a rhombus is a parallelogram. So this is actually going to be always true because a rhombus has 4 congruent sides, yes. That's what makes it unique as a rhombus. But a rhombus is a parallelogram, which means opposite angles are congruent. So that's kind of the explanation I'm looking for, just kind of what theorem lets you know that. So we know opposite angles are going to be congruent, and since it's a rhombus, we know that's true, so it's always going to be true. So then looking at part B over here, angle Q, is it always going to be congruent to angle R or sometimes going to be congruent to angle R? So now we're looking at angle Q and angle R, and these are consecutive angles, not necessarily opposite angles. So the fact that they're consecutive and on the same side right here, they're not across from each other, they're not opposite, they're consecutive, same side. This is going to be sometimes, because we know in a parallelogram, consecutive angles are supplementary, meaning they add to be 180 degrees. But think about the specific type of rhombus we could have. If we're looking back up here, a square is still a rhombus. If this is a square, they would be congruent. It would be true if QRST is a square. So since a square is a more specific type of rhombus, that's why it's sometimes, because no, normally it's not true if it's just a rhombus, but if the rhombus is a square, that gives us our sometimes. So we like these always, sometimes, never questions in geometry. We've seen them a few times before, but they come up a lot here. So kind of using this idea for your homework there. Just always or sometimes true, using your properties. Having this Venn diagram here might help, or your list of properties. Hopefully you guys took time to write down in the beginning. So then moving on to example 2, classify special quadrilaterals. They want us to classify this quadrilateral, so is it a square, a rhombus, or a rectangle? So looking at it, just kind of looking at what we see, we know we have 4 congruent sides. So that fits our rhombus and square, right? If we think about that Venn diagram, that fits our rhombus and square. So we have 4 congruent sides, but there's no 90-degree angles, which limits that square, right? A square has to have 4 90-degree angles, but since there's no 90-degree angles, we would say this is a rhombus. And that's kind of the logic you're looking at when you're going to classify a quadrilateral. What properties does it fit? What properties does it not fit? Limit your choices there. In this case, since we had 4 congruent sides, but none of the angles were 90 degrees, we knew that it was just a rhombus. So then I want you guys to go ahead and pause the video and try these next two on your own. Again, use that list of properties you copied down at the beginning of the video and try this on your own. For any rectangle, EFGH, is it always or sometimes true that FG is congruent to GH? Explain your reasoning. Well, I'm going to go ahead and draw a picture. So we have a rectangle, EFGH, and we know in a rectangle we got these 90-degree angles here. Is it true that FG is congruent to GH? Is it true that this is always or sometimes congruent? Well, it's going to be sometimes, and it's going to be only if it's a square. Since they're not opposite sides here, this will only be true if it's a square, because a square has all four sides congruent. A rectangle has two pairs of congruent sides, like a parallelogram. So that's why it's sometimes. And then number 2 here, a quadrilateral has 4 congruent sides and 4 congruent angles. Sketch the quadrilateral. So we have 4 congruent sides, that means it's a rhombus. 4 congruent angles is going to tell us that they're all the same. So in this case, thinking about what we know, the only one that fits both of these categories is going to be a square. So drawing that picture, we got 4 congruent sides, 4 congruent angles, which means they're all 90 degrees, which means they're describing a square. So that's kind of how those examples go. Hopefully you were able to piece those together on your own. When you pause the video, this is actually shorter sections, lots of just theorems and definitions that you just need to know or have right next to you, so you kind of just look back and forth. It's a lot of just like yes, no, always, sometimes. We will get to the solving portion of everything, but for us right now, it's just really describing a lot of stuff. So we have a few more examples to get through. You might cut it short a little bit, but keep moving forward. Example 3, list properties of special parallelograms. So we know that ABCD here is a rectangle. They tell us it's a rectangle. We already sketched the picture here. And they just want us to list everything we know. And something that I want to be a stickler about here is that yes, we know all these rectangle theorems, but we also have our list of 5 theorems from parallelograms that we can include. So just kind of looking at this list here, well, it has 4 right angles. Right, we can see that from over here. We know that opposite sides are parallel and congruent. We know opposite angles are congruent. We know that consecutive angles are supplementary. And we know that the diagonals are going to bisect each other. And we know the diagonals are congruent. So looking at this list I just created here, specific to rectangles, we have this 4 right angles. That's very specific to a rectangle, only happens in a rectangle. And we have this diagonals are congruent, right? That's also very, very specific to a rectangle. And then when it comes to a parallelogram, all these other ones are just the 5 theorems, 4 theorems we talked about. We kind of combined one for a parallelogram. Sorry, that's a little crooked there, but parallelogram that we use the last 2 sections. So it's just kind of knowing in your head that a rectangle is a parallelogram with 2 extra theorems, 2 extra facts about it that makes it special, and that's why we refer to it as a special parallelogram. And that's actually where I'm going to kind of cut it short for our examples here. The other two I had planned are very similar to this, and I think we can kind of cut it off here. So to wrap things up, here is your homework down there in pink for college prep class. You guys have page 531, 3 through 23 odds. We got a lot of sometimes, always, never questions. It's kind of using your logic. So if I were you, I would have that list of theorems and properties right there and just kind of use it as a checklist and say, is it sometimes or always true for a rhombus? We'll see if you can check everything off. And if you can, yeah, always. So just kind of use that to see if you can work through this. Again, email me always if you have any questions. These notes will also be posted on Classroom. So if you just want to like read through the notes again, if anything was a little blurry or hard to see, you're more than welcome just to read through those notes. Yeah, so this is our last lecture video of the week, so you guys will hear from me again next week. Have a great week.